Hello class, so these are the notes for lesson 2. Turn your notes to lesson 1.2. We finished lesson 1.1 last time, so just turn your pages to lesson 1.2. And this is on understanding proportional relationships. Okay, now take notes. You can use models and ratio reasoning to understand how a proportional relationship can exist between quantities. Okay, so at the end of this lesson, you should be able to look at like a table and the situation. You should be able to look at some bar graphs and whatnot and determine whether two relationships are proportional or not. Okay, so that's the goal, to determine whether the relationship is proportional or not. All right, let's get to this question about baking. So when baking, the ratio of, grab this. I want to grab this pen. Hold on. Sorry about that. Okay, when baking, the ratios of ingredients is important to maintain. The table shows a common recipe for pizza dough. I don't know if you guys ever make a pizza dough yourself, but this is a recipe. You need some flour, salt, yeast, water, olive oil. Maybe you guys have a different recipe, but this is a recipe we're going with. Too much or too little of any one ingredient will not create a good dough. So you got to make sure that you keep the consistent amount of each ingredient. If you put too little flour, or if you put too much salt, or too much water or something, this does not come out very good. So in this recipe, the ratio of cups of flour to cups of water, so let's look at this. So we have flour right here, and the water right here is, we have 3 cups to 1 cup. Okay, so we are going to use the colon right there, 3 to 1 like that, to indicate the ratio. And it says flour to water. So flour has to come first and then water comes later. So please take note of that. If it said water to flour, so if water came first, it'd be 1, 2, 3. But since it says flour first, and flour is 3 cups and water is 1 cup, it's 3 to 1. Suppose you wanted to make 2 batches of dough. You're making 2 pizza doughs. Is the ratio of flour to water the same? What if you wanted to make 3 batches? So we're trying to examine that and see if it's going to be the same. So we are going to look at these bar diagrams here to show the relationship between the flour and water for different batches of dough. In each batch, 3 equal size sections represent cups of flour, and 1 section of the size represents cups of water. So if you look at this, flour, let me try to color coordinate this. Flour will make it pink. Okay, there are 3 cups, and we just talked about how the ratio for every 3 cups of flour, you need to have, we'll do blue for water, you need to have 1 cup of water. Okay, that's the ratio for 1 batch. For 1 batch, we go with that. Okay, all right, the ratio of cups of flour to cups of water is maintained regardless of how many, so it's got to be maintained. The ratio of 3 to 1 has to be maintained regardless of how many batches of pizza dough you make. In each batch, there are 3 cups of flour for every 1 cup of water. Okay, so it doesn't matter if you make 1 pizza dough, 2 pizza doughs, 10 pizza doughs, there has to be consistency of 3 cups of flour to 1 cup of water. Okay, so now we're looking at making 2 batches. Okay, so every 1 cup of flour has to be doubled now because we're making 2 batches instead of 1 batch. So instead of 1 pink box representing 1 cup, we are going to make it represent 2 cups. 2 cups. 2 cups. And same thing with water. It used to represent 1 cup for 1 batch, but since we're making 2 batches, we're going to do 2 cups. Okay, so if you look at the total cups of flour, so it will be 2 plus 2 plus 2, which is 6. And total cups of water will be 2. All right, so we've done 2 batches. Okay, so 2 quantities. When you look at this, 2 quantities are in a proportional relationship if they vary and have a consistent or constant ratio between them. Okay, so let's look at this. If you look at this, the ratio for flour to water for this one was 3 to 1. And this is 6 to 2. But ratios can be written as a fraction, like 6 over 2. And this will be simplified to, if you divide top and bottom by 2, it simplifies to 3 over 1. So you can see how one batch versus 2 batches, they have consistent relationship. They have proportional relationship. Okay, let's look at the 3 batches. For 3 batches, it's going to be for every pink box, instead of representing one cup, it's going to represent 3 cups. So 3 cups, 3 cups, 3 cups. And again, water too, it's going to be 3 cups. So total, you need 9 cups of flour to make, again, 3 pizza doughs, 3 pizzas. And for water, you'll need 3 cups. Okay, so you have 9 to 3, or 9 over 3, which again is going to be 3 over 1. So you can see how this is proportional relationship. Okay, all right, some relationships though are not. So these relationships are proportional. How about some relationships are not proportional? In these cases, a ratio is not maintained. Okay, and we'll look at some of these relationships as well. All right, let's look at this example. It says identify proportional relationships. You have recipe for homemade glass cleaner. So it's like Windex, but you make your own. It indicates to use a ratio of 1 part vinegar to 4 parts water. So 1 part vinegar to 4 parts water. It could be cups, it could be spoons, or whatever you want to use. For every 1 part of vinegar, there has to be 4 parts of water. Elise used 3 tablespoons of vinegar. Okay, so she used 3 tablespoons of vinegar and 12 tablespoons of water to make the cleaner. Is the relationship between the vinegar and water in the recipe and the vinegar and water in Elise's cleaning solution a proportional relationship? Explain. So to set these up, you want to make this into a fraction. Okay, so you could have done this as 1:4, but let's do 1 over 4. Okay, and this is vinegar. We want to make sure we know which one is which to water. Okay, vinegar to water. All right, we'll look at this now. We make the fraction again, ratio again. So vinegar is 3 tablespoons. Let's do it here. 3, and the water is 12. So if you simplify this, remember we always simplify our fractions. You divide top and bottom by 3. It's going to come out 1 over 4. Okay, so this is a proportional relationship. You got to answer this question. Is the relationship proportional relationship? You got to say yes or no and then explain. So our answer will be yes. Okay, I'm going to put a semicolon to explain. The ratio is constant or same for both. Okay, and that's good enough explanation. Okay, because you showed through the work that the ratios are constant. Let's look at the next example. Using the same recipe from before, so we're using the same recipe, 1 part vinegar, 4 parts water. Marcus mixed 1.5 cups of vinegar and 6 cups of water to make his cleaner. Now, is this proportional relationship? Okay, is this proportional to this relationship we saw? So let's take a look at this. All you have to do again is make a ratio. Vinegar on the top and water in the bottom. So again, vinegar over water is what we want. and that's going to be 1.5 over 6. Okay, so this is not as easy to look at because one has a decimal and the other is a whole number, but it's hard to work with decimal and a fraction. So a little trick we can do is multiply top and bottom by 10, and that's totally okay. You can multiply or divide top and bottom by the same number, and it's not going to change the fraction. Multiplying by 10 just moves the decimal over to one space to the right. So that now becomes 15. Instead of 1.5, decimal moved and became 15. On the bottom, 6 times 10 is 60. All right, now we can divide top and bottom by maybe 5 first. And that's going to be what, 3 over 12? We can simplify this even more. Divide top and bottom by 3. And this turns into 1/4. Okay, and as you can see, it was 1/4. Original one was 1/4, and Marcus's simplifies to 1/4. So this is yes proportional relationship. Yes, and we can use the same reason. The ratio is constant. Okay, or same for both. Okay. All right, let's look at the next example. Identify proportional relationships. So a 5-mile taxi ride, or you can think of it as Uber ride, 5-mile taxi ride in city costs Ayana $25. Let's look at that. So we got 5 miles, $25. A 4-mile taxi ride in a different city costs $18. Okay, let me actually use a highlighter. 5 mile, $25. And then we got 4 miles, $18. Assume the cost in the city is the same amount per mile. Is the relationship between the number of miles and the cost between the two cities a proportional relationship? So we want to see if these are proportional relationships. Okay, let's finish this diagram. First city, for 5 miles, they charge $25. And second city, for 4 miles, they charged $18. Okay, so if you look at this, the first one, by the way, when you have two different quantities, always put the money on the top. Money always goes on the top. So $25 for 5 miles. And then we got $18. Oops. $18 for 4 miles. So let's simplify this now. 5 goes into 25 5 times. So this comes out to $5. I'm going to use a space here. $5 per mile. So they're charging $5 per mile. For this one, when you simplify this, it comes out to, you can divide top and bottom by 2. So this comes out to $9 for 2 miles. So if you do, I mean, already you can tell, you don't even have to simplify anymore. 5 over 1 is not the same as 9 over 2. You can't simplify this anymore. Okay, so you can see how the ratios are not equivalent. The ratios for two cities are not same, not equivalent. In the first city, it costs average of $5 per mile, while it costs, so let's look at per mile price. If it's $9 for 2 miles, for 1 mile, half of the 2 mile, 1 mile will be half of $9, which is $4.50. $4.50 in the second city. Because the ratios are not same, not constant, not same. Okay, maybe we should write constant. Not constant. The relationship is not proportional. Okay, so please remember, it has to be proportional relationship for it to be, it has to be constant ratio in order for it to be proportional relationship. All right, let's look at another one. One type of yarn costs $4 for, oopsie daisy, I meant to grab highlighter, $4 for 100 yards. Another one costs $5 for 150 yards, okay? And they want you to figure out whether it's proportional or not, okay? Again, when you have dollars, money, please put the money on the top when you're setting up the ratio. Okay, so first yarn, I'm going to use a space on the margin here. $4 for 100 yards. And second one is $5 for 150 yards. Okay, so this one, when you do your division, 4 divided by 100, it's got to be 0, 0, 0. So 4, it comes out to 4 cents, okay, 4 cents per yard. Whereas this one comes out to, when you do 5 divided by 100, so you got to put 5 in the inside and 150 outside. You put 0, annex a 0, still goes in 0 times. You got to annex another 0. Now it goes in 3 times. And 3 times 150 comes out to 450. Okay, and the remainder here is 50. Annex another 0, another 3. So you can see how this is going to go on forever. So this one comes out to about 3 cents per yard. Okay, so you can see how these are not the same. Okay, so are they proportional? No. The ratios are different. Okay, so the relationship is not proportional. Okay, real quick, one last question. Christine is building a deck in her backyard. She's building a deck. In order to place the posts, she will make concrete using a mixture. The mixture requires 1 part water and then 2 parts cement to 3 parts sand. So there are 3 ingredients. Okay, we got water, we got cement, and we got sand. Okay, and this is 1 part water, 2 parts cement, and 3 part sand. And they want you to figure out. They want to make sure the relationship is proportional. Okay, no matter how much you're making, it has to be proportional relationship. Now she has 25 pounds of cement. Okay, cement is right here, and she is using 25 pounds of cement. She's making a lot, so 25 pounds of cement. She wants to use it all. How many pounds of sand will she need? They want you to figure out how many pounds of sand she'll need. Okay, so to figure this out, the best way to figure this out is ignore the water for now. Okay, and we'll just look at these two. All right, and then make a ratio of cement to sand. Cement to sand is 2 to 3. And we want, again, this to be the same. Okay, so cement is 25 now. And we're trying to figure out how much sand do you need. Okay, so again, these have to be proportional relationship. So what you can do, one of the ways you can solve the proportion is think about how many times 2 goes into 25. Okay, in other words, you can do 25 divided by 2. That's 1, 2, 5 comes down, and 2 goes into 5 twice. That's 4. You subtracted 1, annex a 0, bring it down. That's 5. So it goes in 12.5 times. Okay, and to make this constant, okay, 2 parts of water cement were multiplied by 12.5 times. So you do the same thing for the sand to make it consistent, to make it proportional. So you multiply this by 12.5. So 3 times 12.5. That's 15. 1 goes up. That's 7 and 3. So you need 37.5 pounds. Okay, so you need 37.5 pounds of sand. Okay. 37.5 pounds of sand. Okay, and then it said if she had 25 pounds of cement and you said, okay, we get ready to answer the question. We're not going to answer the last part of the question. Okay, so that brings us to the end of the lesson for today.